All right, so I want to talk about PA3. I want to talk about the main program in particular, and the hash size, and a few other things that seem to keep triggering questions. So let's pin down the gory details on PA3. So let's start with the main program. So you say plate, you're supposed to put in the name of a database and then an optional argument that says how many entries you want in your hash table. So first thing you want to do is parse command line arguments. So this is going to be argc, argv, okay, and we'll go over that in a minute. But you're basically find the database name, and find the database size. All right, and then probably a good time after you do that to load the database into your hash table. All right, so you want to do a hash init and then read database file, and add it to your hash, and do that in a loop until you hit the end of the file. So you need to do an fopen and fgets and things like that, and we'll go through that next after command line arguments. So that loads your database. And then get a command from the user. And process it. And do that until the user hits end of file, and then just clean up and exit. So that's the general life cycle of your program. All right. Look at the command line arguments, figure out what you're supposed to do. Based on that, load your plate information into your hash table, and then get and process commands from the user, and then exit. And the code of your main program can be structured in the same way as this, right? If you like. If you're thinking of this with a different flow, then your main program may be organized differently. So let's start with command line arguments. So real straightforward junk code, right? Just going to declare my main program with the usual argc, argv. Let's just print out argc and return, right? Because I'm never 100% sure what argc is. I know it's going to be either 1 or 2, but I don't know, and I don't want to look it up, and I don't want to try to remember, so I'm just going to try it, right? So I'm just going to run main. It tells me argc is 1, I'm going to say main slash temp slash database.txt. argc is 2. I'm going to do that and say my hash table should be 200 elements. It tells me argc is 3. I know everything I need to know about argc now, right? And here's my template for processing my command line arguments. So if argc is 2, if argc is 2, then the person said plate and database. If argc is 3, the person said plate, database, and size. So that's what I'm going to turn into code eventually. I'm going to check argc, and if it's equal to 2, I'm going to say they typed in the command of, the name of the program, followed by the name of the database. If it's 3, they also specify the size. If it's anything else, they didn't do something right. They either just said plate, or they added more arguments after the size. Okay, so first thing I can do, if argc equals 3, then they specified 2 things on the command line, right? A database and a size argument. Let's see what the size is. Okay, so the arguments start from 0, argv0, argv1, argv2. So this is argv bracket 0, bracket 1, bracket 2. So the size argument is in argv bracket 2. So I'm going to scan that. I'm going to put that into a variable called size. So I'll make an integer size. I'll scan argv bracket 2 into size and print it out. Okay, so if I say main temp database txt 200, I know my size is equal to 200 inside my code. If I say temp database, I don't run that code at all because I'm only running that if argc is equal to 3. If I type something weird, my size is weird. Right? Why is my size weird? Because I tried to use scanf on this string what, and it came back and said what? It doesn't know how to convert that to an integer, in which case it did not change the value of this variable size. Well, I never gave size a value. It happened to be 32764. But it could be something different, 32766. So how do I know if scanf converted something to the size or not? Check the return value, right? And it should return 1 if it succeeds. So if it's not 1, let's print a message. So if scanf does not return a 1, I'm going to print a message and say whatever argument v bracket 2 is not a valid integer. I'm going to return. Because they didn't give me a good integer, I'm done with them. So now if I put in a weird integer, it gives me an error message and it exits. It doesn't try to make a hash table that's 32,000. bytes long. If I give it a good integer, it tells me the size is 200. If I don't give it an integer, then it doesn't run that code at all. So if I initialize my size to 100, and I print my size down here after my if argc equals 3, right, I can specify a table size like that. If I don't specify a table size, my size is 100. Why? Because I initialized it to 100, and since argc was not 3, I did not go through the whole scanf thing to give a value to size based on argv bracket 2.
And you said you wanted to use a global for size?
Inside your hash function, because I didn't specify passing the hash table size to all of your hash code. So that's going to have to be global in your hash functions.
Okay. How would you do that?
We'll do that shortly. All right, so why am I going through this? It's 224 stuff, right? Why am I going through this here? Because what I'm trying to do is parse the command line arguments. Find the database name, find the database size. Personally, I don't want this to go on for the rest of my main program, right? I don't want my main program to be sitting inside a bunch of curly brackets followed 200 lines later by an else print an error message or else do something else. To me, I'm not good at keeping things organized in my brain, right? So I want to parse the command line arguments, and when I'm done, I don't want to think about that anymore, right? And that's the way that I'm writing this main program. That top part is parsing my command line argument, and what I want is that once I get down here, I'm done. I've parsed my command line, right? So I also want to do something about, make sure argc is equal to 2, and so on. And if there's an error, I'm just going to exit here, right? So do something like this, whatever works for you, right? But basically use argc to tell how many arguments you have, which will tell you, is there a database name and is there a size specified? You can use scanf if you have to convert the size from a string to an integer. If there's a database name given, that's just argv bracket 1 that's suitable to pass to fopen, right? And so that's parsing the input. So let me get rid of my printf statement here, because we've already learned what we needed to learn from that. So first thing I'm going to do, see if we have a legal number of arguments. It's got to be 2 or 3. I'm just going to say if argc is not 2 and it's also not 3, I'll print out a usage message. And my usage message will print out the value of argv bracket 0. That's the name of the program you're running. And then it'll say that should be followed by a database, and in brackets I'm going to say it should be followed by the size. If it's in brackets, that's telling the person seeing this, so that's an optional argument. Okay. And then if argc is 3, I'm going to get the size from argv2, otherwise size is just going to stay at 100. So that's a useful comment. And so now here's my size, and if I print argv bracket 1, that's the name of the database file. So if I say main temp database txt, size is 100, that's my database. If I put on an argument, size is 200, that's the name of the database. If I add an extra thing, it gives me a usage. If I don't specify enough, it gives me a usage. And if I have an illegal integer, it gives me an error message. So let's read the database. Okay, so this is how you use fopen to open a file. Fopen takes two arguments. The first argument is the path to the file, which can be just a name if it's in your current directory, or it can be something like /temp/database, right? The second argument, if you put a string containing R, that means I want to read from the file. It won't let you write to it. Okay, so it's opening it for read only. A W lets you write, and there's other strings you can use in there. Okay, fopen returns a value which is a pointer to this thing called a file, uppercase. Okay, it's a structure, it's a type F that's defined in standard IO.H. You never have to worry about what it means for this course. We just say type of variable is file, star, FP is my file pointer. You can call it whatever you want, and it's equal to the result of fopen. Did it work? If it doesn't work, FP will be equal to null. If it didn't work, it'll return null, and we can put out an error message saying we couldn't open whatever that file name argv bracket 1 was. And let's get out of here. We'll return. So if I try to run main on temp database txt, it apparently succeeded. If I try to run main on a file that doesn't exist, it'll give me an error message. Okay, how do you read from a file? Use fgets. So fgets, name of character array, length of character array, and then the thing you want to read from. Standard in reads from standard in, your keyboard. fp reads from whatever fp is, which was the result of opening that file with fopen. So let's print out what we read from the file. With a print statement, we'll print out the value of temp with a %s. And so that's what I read from the file. It's the first line of the database.txt. So let's put this in a loop. I have to keep calling fgets and printing. So it reads from the file until it gets to the last one, and then it just keeps reading the same thing over and over and over again. Control C will kill it eventually. All right, so how do you know when you're done? Fgets will give you a null. Okay, when fgets returns null, it's hit the end of the file. And when you hit the end of the file, fgets gives you a null. So instead of just saying fgets and looping forever, we want to use the return value from fgets somehow to know that we should get out of our loop. There's a lot of ways you can do this. I'll show you one way. So you can say, well, fgets is not equal to null. So this does three things. It calls fgets, which reads a line from the file. It checks to see if it reached the end of file, and if it reached the end of file, it will exit the while loop. Three things for one line of code. Otherwise, it will go into the while loop, and temp will be the thing that it just read. So it will print out that line of the file. So now it reads from the database, it reads the last line, prints that out, and then it just exits quietly. Okay, you want to be clean about this. So when you're done reading from a file, call fclose. And I just learned something new this morning, which is if you don't call fclose and you run valgrind, valgrind will report a memory leak. Okay, because fopen allocates memory, fclose frees it. So call fclose when you're done. All right, so we're parsing command lines. We didn't call hash in it, but we read the database file. Instead of printing the contents of that file, we could go ahead and feed it to our hash adder, right? So there's one place I said you can hardwire sizes, which is in your main program. So I can make up some character arrays, first, last, and plate, and instead of printing this out, let's use scanf. So scanf, I'm asking it to find a string, and a string separated by spaces, right? From what my database looks like, that should pick up the license plate, the first name and the last name. So let's print those out and make sure it's actually parsing the line of the input file. Alright, so that all looks good. So instead of printing those, call your hash add function, add them to your hash after you've called hash init, right? And now I'm done with all of that. I've got a hash table with all my database information loaded. I don't have to deal with command lines, I don't have to deal with fopen, I don't have to deal with any of that stuff. Now my program is just read a command from the user and process it. Okay? Read a command, how do I know if they said asterisk dump, use string compare? How do I know if they said asterisk load, use string compare? How do I know if they said asterisk dump followed by an integer, use scanf? If one of those three things did not happen, take whatever they typed in and assume that's a license plate, hash it to your hash find function, and either say it's not found or print out the first name and last name that you get back from hash find. Alright, so process, get a command process, do that loop. When you're reading from standard in, just like reading from a file, it will return null if you hit the end of the file, which is what happens when the person hits Control-D in the beginning of the line. So the person types in commands, when they're done they can hit Control-D, your fgets from standard in will return null. So do this in a loop where your get command from the user is something like, well, fgets from standard in is not equal to null. When you kick out of that loop, say goodbye, free your memory, and return. Okay, let's make some hash code. I don't remember if I call these first or last, or first name or last name. Anybody remember? Okay, good. Just to avoid further confusion. Okay, so I'm going to have my hash init, which returns a struct node star star, which is also a hash entry star, right?
For readability purposes, is it better practice to avoid type def when you can, or is type def considered more?
You know, it's supposed to make it easier, but sometimes it doesn't.
Because for me, it would probably make it harder to read. Like if I went and wrote this in a year, if I typed def this.
Yeah, so I was talking to someone about this morning. I personally have never used type defs for myself, just because I like seeing that it's a struct node star star, for example, right? But, you know, if you're dealing a lot with complex structures, and your type defs make sense and you know them, right, they can simplify things. But it's not always the case.
So for this PA, is it okay if we just don't do type def? Because it's
That's fine with me, yeah, yeah. If you're doing this in a university, chances are they may be more dogmatic about, you know, you have to use a blah, 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 which is a type def. So you want to, you know what they are and be prepared to possibly have to deal with them down the road. And you know, like uppercase file is a type def. I prefer typing in uppercase file than typing in whatever it's a type def for, which is probably some big long horrible thing. But for stuff that I'm writing, yeah, I usually just spell it out. Okay, so here's the easiest hash init function in the world because it doesn't actually initialize a hash at all. It just prints out a message to make me feel good. So that's my whole hash package because I'm obviously not going to write it for you. Okay, so here's my struct node up here. Here's my type def. I forgot my semicolon. Yeah, it is. Thank you. All right, so so we're doing the 7:45 a.m. Friday morning version of PA3 to have something to turn in here. So there's my main program. There's my size. We've processed all the arguments. Okay, I'm going to yeah, make a hash table with my given size. And I'm going to return here. I'm not going to bother opening the database and reading it and all this kind of stuff. I'm just playing with the hash code here. So I'm parsing my arguments, right? I'm going to figure out what size is. I'm going to call hash init with size, save the result in my hash entry pointer, and be done with that. Not too bad. And I'm going to Photoshop my function just to be nice. Okay, there's my main program. We can run it. If I didn't specify a size, my hash init function got a 100, and it says I'm making a hash table of size 100. If I specify a size, my hash init function gets that size, and it says I'm making a hash of size 200. Okay, let's make one more function here. We'll call this function hash bogus, and it just takes a car pointer. Okay, let's call hash bogus. All right, hash bogus is going to do something. It's going to search for a license plate. It's going to add a license plate. It's going to do something useful, right? To do most of these things, our hash function needs to know how big the hash table is, right? Anytime that we call our hash function, we add up the ASCII codes times I plus 5 and we reduce modulo the hash size. We need to know what the hash table size is, right? But I'm not passing the hash table size to hash bogus. The only time I ever did anything with the hash table size was when I called hash init. Okay, so this is the question of how do we pass the hash table size to these functions, right? So this is what a global can do for us. So inside here, I'm going to do the following. This is my one global to save the hash table size. Integer hash table size. And in my initialize function, since I passed that the size, I'm going to save that in hash table size. And down here in my hash bogus, since I want the hash table size, I'm just going to print out %d with hash table size. And when I try to find the hash table size in here, since it's not defined as a local variable inside this function, it's going to look for a declaration of it outside a function somewhere earlier, and it's going to find this right here. And in my initialize, when I tried to assign a value to hash table size, same thing, it's not declared as a local variable, it's going to look and find this one right here. Okay. So now I have access to that value that I passed to my initialize function anytime I want it. It's just called hash table size, and any of my functions that I define in hash.c can get to that from this point on down. So my hash function itself that takes a string and returns an index, right, can use hash table size and so on.
So a question on sharing that global variable.
Mm-hmm.
So it's proper to, if you're going to put it in a header file, to do an extern declare.
I wouldn't put it in the header,
Okay, why not?
because then it's going to be defined in every file that includes the header. And we don't really like globals. It's really just inside this one file, right? So I'm kind of thinking in terms of objects, right? So this is like my hash class, and it's got a field we can get to. But if you wanted to have it defined in one place and get to it from other places, yeah, you would say extern.
Okay, because I know I
another
can do it this
file.
way, but I was trying to do it the other way. I'm running into issues.
Okay, so
It's just saying
extern,
multiple, declarations of it.
yeah, so you
But
can
I'm not-
only declare it in one file like this, but then in other files you can say extern, and it will look for it when it's been linked together.
Yeah.
Those should be resolved with the address of this.
Yeah, so which is what I did, basically, I declared it in the header file,
Mhm.
extern, unsigned,
Right,
in
right.
size, and then only declared it in hashing it.
Okay,
But
that
it's-
should work.
Yeah, so it seemed that it would work, but I don't know.
But if it's giving you warnings, come show it to me later. And
Okay.
okay, does this make sense? Okay, so let me do one more thing. This is my hash.c. I've got my definition of a struct node. I've got my definition of a type def. This is my main.c. It starts with a definition of a struct node and a definition of a type def, right? And if I've got, 5 or 6 files in this project, everyone's going to have to define what a struct node is, and everyone's probably going to have to define what a hash entry is. And this code gets written over and over and over again. This is where we would use a header file. Okay, I'm going to take this stuff up here. I'm going to put it in a new file. I'm going to call it include.h. And then in main.c, instead of typing all of this stuff, I'm just going to say include whatever the name of that file is. And then in hash.c, same thing. And when the compiler gets to the spot where it says include.h, it's going to basically suck in all of this stuff right there in my file. So it's going to be exactly the same thing as if I took all of this and typed it right here. Okay, it's just saying pull the contents of that file into this file right there. But the advantage of doing this is that I only had to write those lines of code once in this file, and if I need to change it or define some new structure or change the name of my type def because I made it lowercase instead of uppercase E or something, I only have to do it here, right? And every file that includes this, basically, it acts as if it gets changed immediately, but it's really just reading that .h file and including the code in here. Okay, that's really all there is to these header files. They're just supposed to be a convenience. So if you're always typing the same 20 lines every time you start a new .c file, just put it once in another file and just pull it in. And that's what standard io.h is. Now the quotes say look for it in my current directory. The angle brackets say look for it in the system directory. And standard io.h is a file in a system directory that has thousands of lines of declarations for prototyping printf and prototyping fgets and defining null to be 0 and all this other stuff, right? We don't want to type all that into the beginning of every C program we write. So all that stuff is typed into this file called standard.io.h, and we just say include that. But my C program has, a few thousand more lines than I'm seeing right now, because it's got all the lines that are in standard.io.h right there in the beginning. Okay, so get user command. Alright, so this is how we read a command from the user. They're going to put in the license plate they want to find, or they're going to say dump or something like that. Right? So again, you can do this in a while loop. And when the person types Control D, we'll exit the while loop. That's when you do your cleanup and your exit. right? So free your memory and return. So the person has typed in a command. Okay, so so if we want to know, did they type star dump followed by an integer, that's a good time to use scanf. Because we're looking for a pattern that says star dump space and then something that's a legal integer. Succession of digits. So if this thing returns exactly 1, then we know they typed star dump followed by an integer. The value of that integer is in the variable num, so now we can call hash dump or do whatever we want to do. So we can call hash dump to dump the contents of that linked list. Okay. If they didn't say star dump followed by an integer, maybe they just said star dump without an integer. Okay. There's a few ways to check for that. So you can do string compare. And see if the thing they typed in was star dump followed by a new line. Because we know there's always a new line at the end of something that we get from fgets. If you don't like new lines, once you get your value back from fgets, do that string length -1 trick that we did the other day to get rid of the new line. Set temp bracket string length temp -1 equal to \0. That truncates the new line. Now we can just check to see if string compare temp is equal to asterisk dump. Or you can get rid of the new line by doing an scanf with a %s. Okay, there's different ways to do it, but do something so that you can tell if they said asterisk dump or if they said asterisk load. And if they didn't do any of those things, search for a plate using the variable temp. Right, if you don't recognize what they typed as a command, something that starts with an asterisk, then it's just a license plate lookup. And so just pass that to your hash find. So if you look at how these functions are described in the assignment, right? For example, there's a list length function that tells you how long a list length is. List length. Linked list. The load function should go through and show you the length of each linked list in your hash, right? That's just a for loop, right? Go from 0 to the last element in your hash table, which is your array, and call list length on each of those sentinel nodes and print it out. Right? So some of the stuff you're going to print from main, some of it you're going to print from your hash functions, a little bit of it you're going to print from your list functions, in particular list print. Okay, I'm not too concerned about where you do your printing, but do it in a place that makes sense. All right, last thing I'll mention, GDB, when you run your code in GDB, if you need to specify arguments, you can say set arg and just list your arguments after that. Okay, so if I say start, it tells me argc is equal to 3. If I said arg equal to ha, it tells me argc is equal to 2. So you can feed arguments to your GDB by starting off with just set arg and then list your arguments. Right? But you know, another option is if you're developing this in stages in particular, don't worry about your command line arguments too soon. Worry about your hash functions. Worry about your list functions, then worry about your hash functions. Hardwire this stuff. Right? Makes it easier to test. Just start off with your database name being whatever you want it to be and your size being whatever you want it to be, and don't worry about argc argv, right? Unless that's where you feel like focusing. But you know, anything that makes it faster to do the edit, compile, execute, debug cycle, anything that speeds that up is just going to help you. So feel free to short circuit your code, right, and just hardwire some of these things while you're debugging. Just don't forget to unshort circuit them before you submit. All right, is that helpful? Hopefully, because we're out of time. So if it's not, it's too late to go back in time. Okay, so other than more questions on PA3, we will go on to talking about queues tomorrow, and then we'll start talking about trees.
Friends of trees.